Welcome to the K Factor podcast, where we turn up the heat on all things fire protection. Brought to you by the American Fire Sprinkler Association, this podcast sparks conversations about the latest technology, trends, and tools shaping the industry. Join the AFSA tech team as we fan the flames of innovation in fire safety.
Welcome to another episode of the K Factor podcast. This is kind of a unique one. We are at convention, so this is fun. We've got our guest, Steve Scandaliato.
Perfect.
That was good?
Molto bene.
So, Steve, you're principal and managing director at SDG. You've got over 40 years.
40 years
40
this
years.
year.
Congratulations. That's
Yes.
awesome.
Long time. Spotting the dots.
Spotting the dots.
Connecting dots.
Connecting dots, that's a good one.
They took me out of the field pretty quick.
Okay.
So I did have some field experience, but they realized my value was much better. The
Connecting
fitters
dots.
did. They didn't want me out there.
Just connect these things.
He's good enough. Put him back in design. We don't want him anymore. Yeah.
So can you tell me a little bit about your path, or tell our listeners a little bit about your path here and what you've been doing? And
Absolutely. It's always fun to find out how people ended up in fire protection. I always ask audiences, who did this on purpose? Who said, you know what, I want to be a fire protection contractor when I grow up, or even back then, fire protection engineering wasn't a thing.
Right.
It certainly was real, but nobody had ever heard of it as a discipline that nobody knew about. And so I was on my way to born and raised by a general contractor. So I knew what liquidated damages was like when I was 14, right? I didn't get paid all of my allowance when I was 14. I only got $4 of the $5 till I got the last dollar at the end of the month when the trash actually did make it out to the curb. So growing up in contracting my entire life, I don't know anything else. And dealing with subcontractors and seeing the ins and outs of what my dad did, I thought, okay, I can do that. So in a roundabout way, after I went to Bible college, and then I went back into the industry, a real estate license when I was 19, and I got my Class A general contractor's license when I was 20.
awesome.
And the building official there in Colorado Springs called my dad and said, he passed the test, but what do we do with him? And of course, my dad said, my God, don't give him a license. Find some law or rule. He can't even pay for pizza, let alone be a contractor, which means I could have built anything but high rises and bridges. And the building official said, well, he's got to have insurance to have the license. He goes, there it is right there. He can't afford that. So they put it on ice long enough for me to turn 21, and then they had to give it to me. But it started in that route, and then ended up at the University of Arizona in the School of Architecture, because I felt like to carry on the building company and general contracting, that would be a real asset. And I enjoyed it. I liked building things. So
A wildcat, right?
Wildcats, yeah, Ludos. And I headed down that way, and of course, Mom and Dad aren't going to pay for out-of-state tuition, so they gave me my little allotment, and I had to make up the rest. I needed a job, and I knew how to draft. I knew how buildings were built. I had all of that construction background. I already, knew what beams and studs and walls and foundations. I knew all of those components and how that all worked already. And so answered an ad and met a girl whose best friend's husband was a fire protection contractor, Tucson, Arizona. Still there today, Cazell Fire Protection. And he gave me my first job and handed me a book, a little red book. It was the 83 edition, I think it was, 82 edition.
Was this when 13 was still pocket sized?
No. It was hardbound now.
Oh, okay.
Yeah, but it was still only, it wasn't novel size yet.
Right.
And certainly not a lot of annex or extra material. I will tell you, there's several of the pictures are still in it that are in there now. How relevant they are. But the big part of that in my life journey was in 8 months of working there, I dropped out of the U of A. I was just enamored with, I remember sprinklers, my first conscientious view of them was at the grocery store that my mom shopped at as a kid. And I honestly thought they were part of the ceiling system because the grocery store people hung the flags, hung the signs for the aisles and stuff from them. So the fact that water came out of them or they were fire or anything, no recollection of. And back then you didn't sprinkle hardly anything but bigger warehouses and buildings. So I saw how unique it was. I saw the challenge of it, something that intrigued me from in terms of building things, designing something and seeing it come together and seeing it actually built. And that put me in a very strong position, I guess, to move forward. Career advancement became a challenge. And it's then I thought, well, how can I climb a ladder? Where do you go with this industry? And it didn't take long before I learned about Maryland and OSU, and I began to recognize that, that's where the engineering piece of it or that side would go. And then there was the contracting. And I was too old, I guess, and dug in. I had a family and was raising kids, and I was to try to stop everything and go spend 3.5 or 4 years to try to get the degree. So I decided I'd work my way there because it's always been the goal. And worked in the contracting for several years, got a good base. I was able to take an opportunity as the director of technical services for Central Sprinkler because I was really good with their SprinkCAD program. Steve Meyer took a liking to that because he was really pushing the SprinkCAD program at that time. And so I got into that and was there. That gave me a whole different view of the industry and to see a room full of women screwing sprinkler heads together. And of course, the first comment is why women, and it's because of the dexterity of their fingers, right? There was no guys in there. So they're putting all of those Model A heads together by hand, and in this huge facility. So seeing all of that gave me another whole view of it and perspective and appreciation. And that's when I started doing the training, and I was involved in AFSA then. And from that point on, then it was just a matter of time. I worked for another contractor for a little while, and then I started my own consulting and engineering group.
Awesome. So that's, we're here and I was just in an emerging technologies seminar. So it's kind of interesting because there's a lot of things going on, but there's also some stuff that hasn't changed. Right?
It's interesting you bring that up because my wife and I were just talking about that. I was sitting there going, okay, I'm on the backside of what is still a great career, and I have no intentions of getting out right now, not yet, but I can see the metamorphosis that takes place in every generation because I came out, we were on a board and a light table and everything was by hand and in dimension, you had to be able to run a calculator. And then I had luckily gotten exposed to AutoCAD 2.3 or something like that in 81. And the colleges first started having it. And of course we laughed at it because there was no mice and, everything was an arrow key and XY coordinates, right? No 3D. So obviously I could draw a lot faster than drawing it on a computer, but when you started bringing in things like calculations and stock listing, well then, every job has its one thing you don't enjoy. Well, stock listing
for sure.
Yeah, that as my old design manager used to say that you have to stock list your jobs, and the reason why, or let somebody else stock list the job, and then you'll find all your mistakes. That's the easiest way to do it.
And it's got to be done well.
And it does. And so it was a necessary evil, but still, I would like to get to that point a lot quicker than remembering takeouts and all the rest. So that's what drew me to SprinkCAD and the automation piece of it, and trying to sell software at that time and get people to pay 10 grand for computers and plotters and learn AutoCAD, learn how to draw on a computer. That is what I see now. I just sat in that same deal, and I thought everyone's, has looked at me and come in trying to sell me Revit. And no, I'm not going to Revit. And I've realized, okay, I'm either going to have to do that, or I'm on the backside now, right? I'm the older school guy, and that realization really does have to set in, because right there in one of the questions was, AI will connect the dots, and I can actually see that now. I mean, it's hard to visualize that till he started talking about the BIM part, because up until now, Navis and 3D, I've had, a lot of older designers like me, we've adapted and we've learned and we got our way through it, as where the young guys are coming out and they're already proficient. You can't tell them to draw something before it's out of your mouth, they've already done it. Right? It's so quick. So you have that coordination, and now all of it built in. So what's left, and the two things that I see are left, is somebody still has to spot the dot, and somebody still has to physically put it in the air. Now, we were at lunch kind of discussing the fact of which one's going to go away first. Are they going to build robots that'll put it in the air, and we lose the fitters, lose their job? Or do the designers, the PMs, the guys up front? So I think designers, we're going to have to reinvent ourselves, and especially the younger guys are going to have to recognize that they're going to have to work with this. I'm not saying it's going to wipe out designers completely, but there's certainly going to be a different interaction there, because for me to just press a button, or for it to look at the model and lay out the heads, like the speaker was saying, that's like we're talking about today. There's going to be quite a bit for it to learn to be able to know how to do that. So I think I'm safe until I'm ready to retire.
I feel like on the design side, though, I don't know if it's really going to get rid of the designers. I just think the job role is going to change, in the technical know-how and the nitty-gritty of 13 is really where they're going to have to make their money, because simple layout in a fairly square warehouse, okay, sure, it can boop, 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 and all your dots and whatnot are there, and it can do most of that fairly simple work. But I think where we're going to really have to become more proficient is those weird situations where the AI is not going to know exactly how to apply these weird code requirements in these more unique. How do I deal with this odd-shaped room, or the architects are going to come up with something crazy, because now we can 3D model, and our technologies are changing, our materials are changing.
It's exactly.
So it's going to be like, okay, what do I do in this office
scenario? And you're seeing, and he said it. There were some really good points there. And I've said it for years. Is in SpringCAD, HydroCAD, the early programs, that you could draw a polyline around the room, lay in ceiling tile, lay in lights, and I could SpringCAD, HydroCAD, both. You press a button, it'd tell it light hazard, what head you want it, and it'd put the dots on the page. You could even center it, or quarter center line. Quarter tile with it. They did that back in the 80s, right? Take the ceiling away. All bets are off. The minute you get rid of the ceiling, then that's when spotting the dot becomes a big deal. And that's why this whole Spot the Dot series was all about.
So I've gotten to, and that's part of where the podcast come from. Hear some of it, right? It seems, of course, in our role, it's so busy, so you get what is Spot the Dot? And it's a great concept, and it's a great learning sessions. What have you noticed?
It was born out of topical conversations about learning the obstruction rules, right? And learning how to do hydraulic calculations. And those seem to be the two big things that designers, how do you lay out sprinklers in a space? And what influenced that? And that's when the light bulbs went on. This is back in the early 90s. And I realized we're raised in 2D. We're raised looking at a plan view. And that's how designers are learning. Plan view, plan view, plan view. And everything, including our AHJs, we're all in this same boat, in that we put a dot on the paper, and then you measure 15 feet, 7/6 each way or whatever, and there's the spacing of the head. That's what that head can cover. but you put it up against a wall 3 feet away. Well, a sprinkler doesn't know that it's only got to throw 3 feet this way, but 5 feet the other way, right? So what is the influence that has on hydraulics? I get calculations today where they use the actual square footage of the sprinkler and not the assigned square footage of the sprinkler. And they don't realize that, right? And consequently, the inspectors and AHJs don't know it either.
Right.
So that gets changed in the field one way or the other. And now the calculations are at risk.
Right.
It could affect them, couldn't. But just because it's, this whole idea of 7/6 and is upright or pendant, those days are so
all
far
perfectly
over.
square.
Right. And so to your point, I recognize that all of that is good information and the obstruction rules and all the rest, but where does that originate? And that's where I came up with that starts with occupancy, right? And back all the way up through, not as much anymore because Maryland and OSU are kicking out more guys, right? We know we have fire protection engineering as a real discipline in the built environment now, even more so than ever before, which is great. But we still have high school diploma people, smart people like me, no big degrees and everything, but can add, subtract, and can read. And we're relying on them to say this is light, ordinary, and this is extra. And because it's written in a book, and even in the annex, we put this list. And I challenge people that, that's where it starts. It's all about area, density, minimum Q, right? So the number one hydraulic, the sprinkler design 101 in a mathematical form is density times area equals Q. So
Q being flow for the
flow,
listeners.
yeah, I'm sorry, minimum water, right? So where does density come from? Occupancy.
Got to get that right.
You got to. It all starts there, and who's making that call? You, an engineer, a building official, and so often, even today, it's the designer looking at the name of whatever it is in the title block, right? And you get this sense that, oh, that's office space. Well, because it's an office building or something on the title block. Some of the great examples today, right? Churches. It used to be in the old days, church was a church was a church. Drive down, see the cross, steeple, you knew that was a church. Nowadays, you go down and see a retail building with a neon sign of an old retail building that's vacant, and now it's a big, huge mega church.
Concert hall, storage.
Right? Storage. And I would argue with, to some degree, not all churches are light hazard.
Right.
I mean, anybody's been in a Catholic church, whether you're Catholic or not, there's some fire load in old Catholic churches, right? And we even give people matches to light candles all around the place. So restaurants, it used to be a restaurant. You sat down, they brought your food through some doors, you ate it. Where I eat is light, where they cook it is ordinary. Why is it ordinary in there? And it's light where I eat it. And it's all because of this idea that there's a fire, there's stoves and ignition sources, whatever, in a commercial kitchen. You've been in a commercial kitchen. It's stainless steel.
Yeah.
And
tiles.
The only thing that's going to burn is my food. And that's over a grill that's got an extinguishing system, right? We have a dedicated system to the fat fryers and all the rest. So if you take that out of play, what else is there? And so the wall began to move, right? Now you go to restaurants and they're cooking and eating in the exact same space. There's no solid barrier there. There's no firewalls or anything else.
Well, in those spaces, it also seems like they have the bigger flames, the hibachi grill or whatever.
Exactly.
And we see the amusing videos of them torching a sprinkler.
yeah, exactly. And great YouTube stuff. But it just goes to show how delicate, how fragile that list is. The theme bars and restaurants now, the canoes hanging from the ceilings, and my classic example is the one that I to this day I have a hard time going into, and a good friend of mine at the time knew I was paranoid and a big advocate about 2 exits and knowing your space and everything. And so he took me to a restaurant. And as we went into this restaurant, we actually walked through retail area. to get to the hostess stand. And I notice as we get to the hostess stand, it's darker and darker and darker. And then I start hearing animal noises, and I begin to understand that this is a different kind of place. And then I come to the hostess stand, and it's basically dark, and makes you feel like you're in the jungle, and there's all these electrical animals, elephants, and stuff. And then, of course, to me, as sprinkler guy, I'm looking at a ceiling that is made up completely of the worst commodity class in NFPA 13 short of flammable liquids. Group A plastic ceiling.
Expanded.
With monkeys hanging from it and everything else. And I said, there's no way I'm going to sit here and enjoy a meal. I just can't do it. So I'm looking for any signs of a sprinkler head that I could find.
This makes me feel so much better that I'm not the only one.
Oh, man. Yeah, no. And, of course, my family loves the play on that. But yeah, so here again, who's making that call? It's a restaurant. Oh, okay, well, where you eat is light hazard. All right. So that restaurant is not light hazard. There's got to be some kind of engineering or something done to that. So the built environment changing, of course, in terms of our spot the dot piece was, who's calling that density? Because with that comes the area, which then produces the minimum GPM, which it turns around to formula number 2, which is Q over K squared, solve for P, Q over K. And the third formula then for a designer, because they need to remember this, is of course, once you determine P, formula number 3 is P equals $.
Yeah.
So the higher P is, the higher the $signs are. So that's the game that we play, trying to get the dot as close to the line as we can on our water supply. You take that away, so to me, that's what starts the influence of where I'm going to put the dot.
Hazard classification is 1.
Big. Number 2, you cannot, and this is big with the AHJs that I'm doing. A big part of that inspections is you cannot put a dot on the paper without defining the construction. You have to have the construction definition. And this goes back to previously what we talked about is water on the floor. Well, unless it's extra hazard or special hazard, it's not about water on the floor. Light and ordinary hazard predominantly is about cooling at the upper levels. It's control, like we were talking about earlier. And to remind people that that's the NFPA 13 committee is these rules are based about control until the fire department gets there. Every one of these has a duration to them. So have you ever asked yourself what happens when the water's gone? If I have 60 gallon or 60 minutes of water outside in a storage water tank, what happens when that's all gone?
Really bad news channel.
Yeah, exactly. well, that or you've got a real slow fire department, right? So I guess I've always felt like you keep your eye on the ball. So what is the number one thing about, especially in light and ordinary? We get to storage and special hazards. That's a little different, but. Guys, the head has to go off.
Activation is key.
I can have all the perfect spray pattern, every square inch is going to get water, no obstructions. I add heads till kingdom come, but if they're not in the right position to see the heat, in the sweet spot for the heat, and they don't go off early enough in that fire development, then we lose, right? So what drives that? The Z dimension, and the Z dimension is driven by the rules based on the construction definition. So subconsciously or consciously, every designer does that. You get a reflective ceiling plan with ceiling tile. Well, smooth ceiling, it's 1 to 12, and away you go. But again, you move the ceiling away. Now what is it, right? Is it 1 to 12? Is it obstructed or unobstructed construction?
Well, and one of the fun discussions we like to have with the designers is everybody thinks, obstructed construction is so bad that I don't want to be obstructed. No, the obstructed construction gives you a little bit more wiggle room though. So that might not be the worst thing.
I would argue that all the time. I would much rather be in obstructed construction with big, heavy wood timber beams
100%.
than any lightweight bar joist tilt-up concrete building in a heartbeat.
Less conversation with the field, less frustration.
Yes.
You got wiggle room.
Yeah, way more wiggle room to work around everybody else.
But here again, then you have that perception that all of humanity has. You think the further down from the deck, the less sensitive I'm going to be, right? So it really, for me, became a really great learning experience with a lot of smart guys and getting to learn to use FDS enough to be very dangerous with it, but to recognize it's as much as I'm worried about water on the floor, a very close second is for me to understand, where does the heat go? How does a fire grow? Fire growth, and where is that in relation to sprinklers? And boy, when I started to learn that, then that got taught to me as well as confirmed for what I believed and recognized that's when Spot the Dot really came out. Because then I recognized, okay, what people are assuming is that it's either bar joist or ceiling tile, and that's not the case. Anybody who's been in a mechanical room recognizes that it really is not always structure either. You can have a conglomerate of stuff, duct and cable tray and whatever else.
Stuff's a very polite way to put it, yeah.
Yes.
All the other trades.
Yeah, everybody else. And they're close enough to the ceiling that, is it an obstruction or smoke and heat don't care if it's an I-beam or a duct. It's going to affect the way that goes. So the name of the game for me is, what's the best place possible for me to put this head for it to see the heat early enough in fire development to go off so that I get the cooling first. And then what water I get on the floor, I get on the floor.
That's great, yeah.
Right? And then driving from that, then of course, we can't ignore obstructions. There's 4 obstructions to spray pattern, that with the beam rule, the pattern development rule, the discharge rule, the vertical rules. And to me, a designer should have those memorized.
Yeah,
now,
sure.
not the beam rule tables, but be able to identify very quickly, whether it's during design or coordination, that, hey, if I just drop this, I can drop this head another 3 or 4 inches, I'm good, or I need to add heads on the other side, establishing what that obstruction's doing to you. And you have to temper that with, every time you put another dot, then that's more money, right? Which the estimating side and the business side cares about.
And the holiday bonus side.
And exactly. Yeah. How am I going to put my kids through college side?
To dovetail on that, though, I think talking about newer technologies earlier, I think a lot more of the BIM modeling, where we're able to see more of these spaces in 3D, I think will also kind of help with some of those obstruction rules, because you'll be able to not just see a dot in a 2-dimensional plane.
Exactly.
It'll be more easy to see that sprinkler in that space with that beam or whatever, and better visualize those
Absolutely.
really helpful diagrams in 13 that always are just
totally
so
agree.
well
And
illustrated.
going to college, right? Like, the degree is great, but I know I don't have enough, as I'd like, contracting experience. You get out of school and it is just an office building until you've been in the field and you take a look and do site visits or see your BIM drawing. So,
Yeah, to see it in real life.
Yeah.
It is. To that end, though, don't shortchange yourself, because that to me is the other side of it. I can be really good at following rules and coming up with all of this, but at the same time I can identify it. But then the solution for it, well, that takes some engineering. That takes
full
somebody who
building
understands
system.
fire growth and understanding heat transfer and heat release and all of those things. Then to give you a complete picture. But I think understanding the construction definitions, unobstructed and unobstructed, those more than anything, I think, are the what's missing in our training, or the emphasis for it. But to your point, it's a lot easier to teach it now, because now I can see it in a NAVIS model or a BIM model, and it's 3D. Whereas before that, I remember when NAVIS just had come out, and I was, thank God I could finally see what my third eye had to do all those years, what a beam, because I knew what a beam was. But now with new designers, you have to teach them all the nomenclature of how to read a structural, how to read HVAC, what the W10 means, what's the width and the height of a duct, which is first.
the annex of the construction definitions, so helpful.
All of those, yeah. And so it's like fire protection design and the engineering piece of this has to know a lot about everybody else's systems in order for us to put that down on the paper. And I think that's why the whole AI thing, I think, will be a challenge to get to that point, like you were saying. But I can certainly see the day that, given a model that's built in real time in a cloud and everybody's contributing to it, where that can be a lot easier way to identify.
But I mean, to your point, we had so building type activation, occupancy classification, and obstructions. That still is going to need no different than the plan review, right? There's more, but even with AI, someone's got to look at those things, make sure they're accurate.
And that
and
they're
make sure
real.
that somebody put the right thing in, right? Because if you just pull it right off the plan, kind of like what you were talking about earlier, it says kitchen in my office. But are we talking kitchen with cooking equipment, or are we talking kitchen where it's a microwave and a refrigerator?
Yeah.
Like,
And that's to me where I'm a little skeptical about letting I'm sure we could get to that point in time, but think of what you just listed out. You got to sit there and type all that in, or check a box
Good
for
prompt.
all this wizard you got to go through, so the computer knows all those situations, all those aspects of this space, and then boom, yeah, here's your head layout. But can I lay them out just as fast as it took me to type all that information in and give it all that background to be able to do it? Like you said, a warehouse might be something, a hospital, no way. I think it'll be a lot more beneficial for a hospital type of ceiling space situation as far as coordination is concerned. But
If we need as-built, we still don't have them.
no,
You can't feed the as-built in. 'cause we
no,
don't have them.
and now if they're going to do the scanning, like he was talking about, to a half an inch. I mean, the scans I've worked off of are good, good information.
Yeah.
There's something right in that area, so I'll move a foot over, right? A quarter of an inch, half an inch, a degree of accuracy in the as-built. I'll start teaching. I'm not going to keep doing. But then the final thing was water supply, right? So occupancy, construction definition, obstructions, and then the water supply. And that, as of late, has become even more prevalent. I mean, when the Palisades went up and water supply was gone, right? They had no water.
well, I mean, it's also not, because one of the big things there was like, there's not enough water. Well, we also didn't design for how much
water?
Fires going at the same time when we're trying to flow a ton of apparatus there's no water supply. It's going to keep up with that. We were never designed for that.
And you know this, the codes aren't built on double jeopardy. So we're looking at, a fire in a room on a day at a single time, one at a time kind of thing, for no other reason than money, than cost, right? And the perception that we have infinite water supply just because we're hooked to a city water. Well, okay, time and history will tell us that's a pretty good assumption to have. We're okay with that. In normal built environment stuff, I've as of late, the last 15, 18 years of my career, have been in oil and gas and petrochem and industrial and special hazards and 5,000 GPM pumps, four of them,
pressures,
big, 24-inch pipes and stuff. And you begin to realize, water supply is a big deal. But stop and ask yourself, after 60 minutes, and the fire's not out, right? So keep in mind that we're designing for a hazard based on prescriptive that says 1/10 gallon of water per minute per square foot and 1,500 square feet for 60 minutes ought to be enough. Mm-hmm. Well, yeah, I'd say so. And I think that's why we get lazy about it, or we kind of put water supply on the back seat because we're so successful. We were talking earlier in the NFPA journal in the flashpoint, you can read success after success, one head, two heads, fires out when the fire department got there. We have this great track record. So we just assume that it's always going to be there. And to me, who that's the other piece. Who calls out density and who calls out water supply? And there's all the conversations about layout versus engineering and all the rest. And I think from the contractor side of it, I've really tried to advocate the fact that, the liability, especially in the 21st century, is the engineers of record have to step up and pay attention.
Well,
And I
do
joke
this.
around,
Stop.
work so hard for my stamp, and then you get to a point where you don't want to use it, right? You're like,
Yeah.
how do I not?
Look, sweetheart, that's what I got. Yeah, and until you said, oh, well, this is how much it's going to cost every
Right.
year to have it, right?
And the liability. I mean, that's the
That's-
other thing is like, I just don't.
That's one of our big conversations every year is, do we still need that E&O insurance? And it's a matter of risk, what kind of project you do, lots of factors are in it. But to me, it can boil down to that. The 13 has all the other rules. I mean, Kevin Hall is a walking encyclopedia. Yeah, exactly. If we could just clone his brain and put it in a jar. There's all the different idiosyncrasies of the different systems, dry and pre-action, and all the drains and the sloping and the timed water and all of those things. But to boil it down to, for me, is I put my head on the pillow, is the system going to work the way I designed it,
For sure.
right? And for AHJs, it's the same, right? They don't want to be on the hook, right? They don't want to be the one that said, okay, ta-da,
Yeah, you're good.
it's accepted.
Uh-huh.
So what are those, boil it down to just those things that make or break the system working the way I wanted it to. Beyond inspection, testing,
Right.
and maintenance, right? Rocks in the pipe or whatever. That the head is going to go off early enough in fire development. I'm going to get the cooling, I'm going to get the pre-wetting, and we win.
Right.
And that is the construction definition, right? The occupancy and putting the density out that I need to. That the head is in that Z dimension. Don't learn and memorize the construction definition rules. And it's not that hard.
Well, and then kind of adding on the water supply, also remembering that you're taking a snapshot in time, and hopefully you've done your homework and you're getting it at the worst time of year while it's under the most heavy usage and whatnot. But like, if you're looking at a water supply, hey, I need a hydrant flow in the area, and the city goes, okay, here's one that we did. Oh, when? Right, was that 2:00 in the afternoon on a random Tuesday when we weren't using the water supply? And then we're trying to bump up to that line, and then we're wondering why the HJ is pushing back, saying, I want a 10% reduction.
Exactly.
So then those are the conversations that, like, if you don't spend the time to dig into it,
You'll end up in a lawsuit.
Yeah.
You'll end up in a lawsuit, and I'm an expert witness on one right now for that very same reason. Is the contractor did the due diligence up front. The fire department gave them the water supply for it. They designed to it. Year and a half later, they're finally doing standpipe hydros and hydrostatic tests on the standpipe of the 6-story building. And it's failing. And come to find out, there's not enough. They lost somewhere in that year and a half. The city water supply dropped 20 PSI. And this is a major metropolitan. If I told you where it was, you wouldn't believe it. And they're in a lawsuit because now the owner's not going to pay for a fire pump. So the covering those bases, I guess, to me, and again with the HJs, is what's most important, and that's the other side of it. Is, I tell them, I go, you're coming to an inspection to inspect a design that was approved based on pictures on a paper, right? So that rough-in is about validating that, yes, what I said on this paper and what I showed is actually what's going to be installed. So why is it that the inspectors show up and don't have those drawings with them?
Right.
So I know how things are going to go with one of mine, and I'm there for the rough-in, not the fitter, because the fitter isn't going to defend my design. Right. So I think those are a couple things that I really admonish contractors to do, is when there's going to be the rough-in inspection, let the designer go out there to be a part of that. And I know the hydro is the big thing, but are they going around and saying, is this 1 to 12? Is this unobstructed construction? Even that basic question. Because if it's not, then all bets are off if the deflectors are where they need to be for heat.
right. Well, and then, of course, I can't not tag into the ITM discussion because,
Then
where I'm at heart.
it
right?
gets
But-
maintained, so everybody signs up. Think about this: a fitter and a rough-in inspector, firefighter, are our last chance of getting it right. Right? So you've got an engineer, maybe, you got a designer, you've got a project manager, you've got a plan reviewer, you've got 3 or 4 people looking through this document before it even becomes something. And then the last 2 people that really get to say, you know what's right, no matter whose fault it is, that's our last chance. Because once it's accepted, it's going to stay wrong for the next 50 years.
Well, and then we've got to make sure that accepted, good, bad, otherwise, that's our baseline that we're going to. So those main drain tests, the flowing for our private fire service mains,
right,
all of that is stuck, but we're also verifying that water supply. Hopefully we got the water supply right. We've got good information, right? And we're keeping an eye on it so it's not degrading on us.
Right.
But then it's also, we're stuck with whatever decisions were made, good, bad, or otherwise.
That head's 10 feet off the wall, it's going to stay that way for 50 years.
Right.
So that's why I guess I feel like if we can just give them just this little capsule of that part of all the other nuances of the system, if we know that, then we've got a really good chance to sleep well at night, that the system's going to go off when it's supposed to, that the head goes. Yeah.
So what's your favorite part of AFSA conventions and expos?
Oh, I think the parties
Parties are pretty good.
are good. You know, for us, over the years, the networking, being able to interact with people from, one end of the country to the other parts of the world, and hear struggles that they have that are the same as mine, or not. Things that I don't have, they're completely different. And a lot of times in conversations, you can say, "Hey, I've been through that. I can help you with that," or "I know somebody. Here's a card."
Or this was the solution I came up with.
This is how I did it
for you. Or you're like, "Hey, I've got this weird situation that I'm in. What do y'all think?"
Yeah, I almost every convention at one point or another, I'm sending details that I've done to some other engineer or vice versa. Templates of reports. A lot of sharing of information can go on beyond just making the contacts for sales, right? And that's the biggest part of it is we've got such a great manufacturing base that it is a huge part of the success of this year after year. But the biggest thing I've noticed this year, and I don't know that I paid that close of attention to it, but boy, it struck me this time, was the chapter involvement, the local chapters. When we were getting the little ribbons, you put on your thing, and I see the list in Sprinkler H, and you don't skim by it.
Oh, for sure.
But this time, and I saw all of those chapters, I thought, holy cow. And then in Sprinkler H, I've got myself now where I'm caught in this habit of reading all of the things the chapters are doing, and it's way beyond playing golf and burn center checks that we've been doing for years, which is all good stuff. But legislation changes, the stuff on labor, the attack on our NFPA codes right now. That's
education of younger audience,
and the education,
the chapters are also pieces. Bringing up definitely the training. I mean, it seems like a couple of those chapters have really kicked up on their training. They're doing really good training that's needed in the industry right now, just to get people up to speed with what's happening, what's changed. Because I feel like our codes and standards are not necessarily, they're still on a 3-year cycle, right? But I feel like we are changing more and taking bigger leaps than we've had in the past. And I feel like the rate of change, just with the rate of technology.
Agreed. And I think it'll only probably go a little faster now that we have AI. I think we're going to get there a lot quicker because we have a place to go that goes and finds all that knowledge and gives it to you. We used to call that an encyclopedia.
Yeah.
And we had to read it, but in my day. But now I can just type it and I get it fed to me. So
I got a final question for you. If you were a sprinkler, what kind of sprinkler would you be and why?
Oh, yes. I'd be a EC25.
Okay.
Oh, yeah.
Very versatile.
Go big.
That's right. You can go
pressure.
Average or standard.
Go. Yeah, a lot of pressure and go big.
That's right.
Yeah, I'm not none of that residential 2.8 stuff. I could spit what's required out of a residential sprinkler. No, I want to I want to rain down.
Yeah.
For sure. I want to make a difference. So
We've spoke about it. This is going to be one of many. I always appreciate talking to you. The conventions, learn so much from you.
that's great.
And I think our next one is probably going to be water delivery time, dry pipe systems, and it should be good.
How to design for them.
Yeah.
Some really unique things I think that we can give guys a heads up on. Even seasoned designers probably don't recognize some of the differences they can do in just the way they connect the dots to get the water where it needs to be quicker. So looking forward to it.
We really appreciate you being on.
Oh, this is great. I appreciate it too. Thanks, guys.
Thank you.
You bet.
This has been the Cape Factor Podcast. If you enjoyed the show, don't forget to like, subscribe, and share wherever you tune in to podcasts, or head over to our website for more. Reach out to us anytime at technical@firesprinkler.org. Stay safe and always learn as we keep the fire protection conversation going.